All right, so now we're going to be kind of working on, sorry, I'm trying to fix this over here. Now we're going to be, instead of an ordinary annuity, we're going to kind of walk through an annuity due. The front end stuff won't be quite as dense as we just did with an ordinary annuity. So the rest of these will kind of start to move a little bit faster than that one did. So let's kind of illustrate this just to kind of get an idea. And again, when we talk about annuity due, the timing is a little bit different in that sort of looking at this. If you remember with the ordinary annuity, the first payment didn't happen until the end. But with an annuity due, the first payment happens immediately because everything's at the beginning of the period. So you can see that the $10,000 now grows differently, right? Because now it's going to have interest. That first payment is going to gather interest after 1 year, after 2 years, and after 3 years. And then the second payment is going to get interest for 1 year and 2 years. And even the third payment is going to get interest for 1 year. So when you have an annuity due, notice that the future value is more. With the previous one, I think the future value is like 33,100 or somewhere around there. And so you can see it's a important difference, right? And so now, because of that extra period of interest on every single payment, the amount of the value of the annuity is more. And so again, it's got more time. And so now the interest is going to work for you a little bit longer in terms of how much money is going to be in that account. And so that's kind of how it's illustrated in terms of timing, right? So you can see the timing shifts the payments. Since it shifts the payments, it shifts the value. So looking at the equation, again, we're gonna go quickly through this, but again, this is, kind of illustrating the idea of how this works. So, the first $10,000 gets interest 3 times, the second $10,000 gets interest twice, and the third $10,000 gets interest only once. So we're just kind of illustrating that picture. Similar to what we did before, we're going to arrange these in a geometric progression. Again, the key mathematical concept with annuities is this idea of a geometric progression. So the progressing term, again, is 1 plus the interest rate, and it goes from the first power to the second power and to the third power. So that is a geometric progression. And so the way that we solve that is, again, we take both sides of the equation, we multiply it by the progressing term, and then we subtract the first equation from the new one. So again, this is that second step, multiplying both sides by the progressing term. So now it's, notice it's squared, cubed, and to the fourth power. And as you can imagine, then when we subtract the two, similar to what happened before, the middle terms cancel. And the only thing we're left with on the left-hand side, of course, it's very similar. Instead of an ordinary annuity, notice that it's got the D, which means it's annuity due. And then you just have that term to the fourth power, and you have a term to the first power. And so we're going to take that information and we're going to rearrange it, and we're going to try to simplify it so we can understand where the factor comes in the future value of an annuity due table, where that factor comes from in that table. And so again, simplifying that, you can see on the left-hand side, we factor out the fair value of an annuity due. And on the inside, again, we're going to have the 1 and the 1 are going to end up canceling. Hopefully you kind of see that. And on the right-hand side, you can see that we have a $10,000, and we also have this 1 plus 0.1 to the fourth and to the first. And so let's kind of walk ourselves through that. And so left-hand side, again, we simplify it. Right-hand side, inside the brackets, we just have the two terms sitting here. So rearranging it again, you can see that we have the annuity amount here. We have the interest rate in 3 different places. So you kind of see that. Now it gets a little bit hectic because you can see we kind of have a weird thing going on inside of here, right? We have to the fourth power, which is kind of n plus 1. Then we have to the first power, which is kind of like n minus 2, if you think of n as far as the number of payments. And so instead we rearrange it a slightly different way when we get to the general form equation. But you can solve this and get 36,410 just like we did before. But I want us to think about how to rearrange this for our general form equation. And this is what we've done, is essentially, since everything's multiplied, we just factor out, or we move out that 1 plus I term. And what that now allows us to do is we have now to calculate or understand how we get the fair value of annuity due. We have the payment isolated, right? So that's the annuity amount. And then this whole term right here ends up being the fair value of an annuity due factor. So this is how it's calculated, where I is the interest rate and N is the, sorry, there's several I's, of course, and then N is the number of periods. And so that is the way that factors are calculated. So again, just try to walk you through this. Using our general form equation, again, the factor, again, that's that second term all together. That's the interest rate in 3 different places. That is the N, which is 3. We can take that and we can calculate a factor, 3.6410. And of course, the factor is a little bit bigger because we have this additional term out on the right-hand side. That term is more than 1. When I multiply it, of course, that adds. And so, interestingly, this factor right here is the future value of an ordinary annuity factor. And so they're very similar, of course, except for this extra term out to the right. And so, again, that term, the 3.6410, is for the fair value of an annuity due factor table. And so looking at that, you can see that our interest rate is 10%, our N is 3, and the factor then is 3.6410. Again, now you can see where that number comes from. Again, I'm not testing you on that. I just want you to understand where the factor comes from for those that want to geek out a little bit. Okay, again, kind of re-explaining everything. And so the way that we apply it, again, anytime you use a factor table, you take the basis, which in this case is an annuity, you take the basis and you multiply it by the factor that you see in the table. So again, we get $36,410. All right, so here's one to do on your own. Go ahead and pause it. See if you can do this on your own. Pause it actually probably on the next sheet, because then you're actually going to see the table. So using the factor table, what is the future value of a 4-year $1,500 annuity due investment if it earns 9% annual interest? And again, each of these factor tables is different. So this is a future value of an annuity due factor table. And again, in this case, it's a 4-year annuity with 9% interest. And so we intersect the 9%. Sorry if I can find it, and 4 years, and you can see the factor is right there, 4.9847. We apply that factor to the annuity, and we get the future value of an annuity due, $7,477.05. Again, hopefully this is something that you're used to doing by now. You're kind of getting more familiar with using these tables. The next one. All right. So this is using the calculator. Now, I will say there's a little bit of a twist to this one, in that the calculator inputs are the same, whether it's an annuity or annuity due. In other words, the N, I/Y, PV, payment, FE, all that stays the same. We do know that the timing, though, is a little bit different. And the only way you can solve for this is by telling your calculator. So you have to tell your calculator that, oh, this is an annuity due. This is an annuity where it happens at the beginning of each, at the beginning of each period, not the end of each period. And so the way you change that setting is, again, you're going to sort of look at your financial calculator, and the way you do it is you hit second, and right above the payment, you see it says BGN. If you hit second and payment, you'll see it now says end. Sorry if I'm doing it the wrong way. Mine says end, which means right now it assumes payments happen at the end of each period. I don't want it to be at the end of each period. I want it to be at the beginning of each period. So the way that I change that is I do second again, and then I hit the enter button, which is set. Now notice that it changed. So second payment, second enter changes the setting from N to BGN. Again, second payment, second enter, second payment, second enter. And if I want to change it back, I just do second payment, second enter. And now it's back to end. And I can kind of keep doing that. Second payment, second enter, and it's back to end. Beginning. Sorry, it's back to beginning. And notice then, once it's in the beginning setting, right above here, mine says BGN, which tells me that I'm in beginning mode. If it's an end, there's nothing there. And so now I know that I'm in beginning mode. I'm ready to now execute the calculation. And so we do know that we're calculating a future value. As I mentioned before, the terms are the same. You know, the N didn't change, the I/Y didn't change, the PV didn't change, and the payment didn't change. And so when we put that all together, again, it's the same 3, same 10. There's no present value. The payment is still $10,000, but the setting has changed. And so since the setting has changed, the future value is going to change. And of course, when we solve, we get $36,410. All right. And so for this, so hopefully, again, just second payment, second enter. Hopefully you're getting familiar with your calculator. By the time you get to the test, you really got to know how to use that. And so make sure you're staying on top of it. Now solve for the second one. Again, remember, keep it at the beginning setting. See if you can solve it. So hit pause here if you need to, and then we'll fill in the information in a second here. Okay, hopefully you paused it. If you didn't, that's all right too. But again, we're filling in the information, right? So the N is 4, it's 4 periods. The I/Y is 9. The amount of the payment is $1,500. And again, we've made sure to tell it it's in the beginning setting because we want to make sure that we're telling it's an annuity due. And so then when we calculate it, we get $7,477.07. So again, hopefully that kind of gets you there. We're going to go ahead and stop here, and then we're going to pick up with present value of annuities, both an ordinary annuity and an annuity due. But again, hopefully this one's a little shorter, but hopefully we're getting there.